We're going to go over problem solving using specifically right angle triangles, okay? Mainly because up to this point we've only learned the rules with right angle triangles. So we're going to have to create this situation here. Karen is a photographer. She's taking pictures of the Burlington Skyway Bridge. She's in a helicopter 720 meters above the bridge and exactly 1 kilometer from the west end of the bridge. The Skyway spans an entire distance of 2,650 meters from east to west. So, whenever we're problem solving, it's best to go over a question again and get the key points. So these are going to be our key points. Karen is a photographer taking pictures of the Burlington Skyway Bridge. She is in a helicopter 720 meters above the bridge. So that's going to be important. That's how high above the bridge she is. And exactly 1 kilometer from the west end of the bridge, okay? So keep that in mind. First of all, meters and kilometers are different units, so we're going to have to do some converting in this question. And the Skyway spans a distance of 2,650 meters. Again, that's all, and that's the entire distance. That's all important information when we go to create our picture. The very first question says, what are the angles of depression to the west and east end of the bridge? Okay, so let's recall. Karen was in a helicopter, how high above the ground? That's right. So it was 720 meters above the ground, this helicopter. So we have a circle. Okay. Les Miserables here.
Helicopter.
Anyways, we got our helicopter, and we know that it is, I'm not sure why this is cutting out, 720 meters above the ground, or above the bridge specifically. The bridge itself was the total distance of how much? It's not 1 kilometer. What was the total distance of the bridge? That's right. So from this being the west and this being the east, was 2,650 meters. They also said that Karen was how far from the west end of the bridge? How much? 1 kilometer, exactly. Okay, so I want you to think of it like this. If she's directly 1 kilometer away from the west end of the bridge, okay, if we were to take that value and just kind of slide it down, okay, that means this red section here is 1 kilometer. Okay, or let's convert it to meters. 1,000 meters. So we know that this distance is 1,000 meters. We want to find the angles of depression to both ends of the bridge. Now remember, when we talk about angles of depression, they have to be drawn from a horizontal line. So I'm going to put a horizontal line in green here. Okay, so here's our horizontal line. And remember, these angles of depression, we'll put those in red, are angles coming from that horizontal line going downwards. So to here and to here. Okay, so the hardest part about these will be setting up the questions. This is our west end, this is our east end of the bridge, and the angles themselves are outside of what looks like the red triangle we've created. Okay, so we actually have to find those two angles in this question. Now we have the height of this triangle, and we can create, because we're going from directly below, a right angle, which means, I guess we'll do that one in green. How far is this distance here if this is 1,000 and the total distance is 2,650? That's right. So we just have to subtract 1,000 from it. So we now have two pieces of information about two separate right angle triangles. Here's the first right angle triangle. Okay, we know that this is 1,000 and the height is 720. Okay, and our second right angle triangle, the height is 720 again, and the distance is 1,650. What would be the quickest or most efficient route in figuring out these two angles of depression? What angle in the triangle would I want to solve first? Let's say of the west end triangle. The top in here. Now, solving that will do what? How will that help us find this?
You can subtract that from 90.
That's right. We can subtract it from 90. And the reason we can subtract it from 90 is, remember, angle of depression is from a horizontal line, and this is a vertical line, which means these two lines, when they meet, make 90 degrees. So the very first thing we're going to do is find the upper angle in here. We'll call this theta. Okay, so for our west end triangle, we'll call it the west triangle. We have theta, and according or in reference to theta, what sides of the triangle do we have measurements for? Well, what side would this be in reference to this? The opposite, and what would this be? Adjacent. So, of the three ratios, which would we use? So it's going to give us Opposite over hypotenuse. Do we have the hypotenuse? So that's cosine will give us adjacent. That's right.
People, it's 10.
So tangent theta.
Come on, Mitch.
Tangent theta will give us opposite over adjacent. I'm sure you love that. So our opposite here was 1,000. Our adjacent was 720. And we know tangent theta is equal to that. Remember, we're finding theta itself. So what do we need to move to the other side? Tangent. And when we move tangent to the other side, it becomes inverse. Okay? So tan inverse, using the value of 1,000 divided by 720. Theta in this case will equal, let's clear that, 1,000 divide 720. Oh, it didn't work, did it? 1,000 divide 720. Okay, and then we do the inverse of tan. I'm in degrees, 54.2. We're going to say approximately 54 degrees. Okay, so what we just solved was this angle here. This is 54, which means the angle of depression to the west. How do we solve it? 90 minus 54, which is going to give us what value? Who knows? That's right. So this will be, so the angle of depression is 36 degrees. This one is 54. We repeat this same process for the east end triangle. Okay? So let's do the east end triangle. Again, which ratio are we going to use? Yeah, because we have opposite and adjacent again. So we're using tan for both of these. Tangent theta is equal to 1650 divided by 720. So we'll try to do this all in one step. I know tangent's got to go to the other side. It'll become tan inverse. Okay, so tan inverse. Oops, that's supposed to be a power of -1. Okay. We're going to put this into our calculator. And our green theta here, we have 1650 divided by 720. And then again, inverse of 10, 66.4. So again, I guess we'll round down in this case, so approximately 66 degrees. So if this angle here is 66 degrees, what is the angle of depression? It is. Very good. It is 24 degrees. Good. So we've answered the first one. Angle of depression to the west is 36. Angle of depression to the east end of the bridge is 24. Second question says, if Karen has a camera of 150-degree lens, can she take a photo of the whole bridge from where she is? Well, in other words, what they're looking for is if she's taking a photo, she's going to need to encompass this entire area here. How large is that area? How can we figure it out? We add the, that angle, that angle. We add the two interior angles we have. So 54 and 66. Okay. So what are we going to get in the end here? 120. Her camera has a 150-degree lens. Can she take a picture of the whole bridge?
Yeah.
Yeah, her camera is large enough to take, or has an angle large enough to take a picture of the entire bridge.